All right, my friends, let's see how far you got. Question number one, what should we let u equal and what should we let dv equal? I hope it makes sense. I'm going to focus in on x squared here. If I take its derivative, it gets simpler. If I take its antiderivative, I think it doesn't get simpler. And then as far as cosine goes, it's kind of a cycle that it would go through. And it's kind of a wash. Like when you take its derivative or antiderivative, it kind of does the same thing. Like you're not at much of an advantage either way. Anyway, but I'm going to go ahead and show you that letting u equal x squared would be the wise choice for this problem. And then that would leave cosine x dx for the dv piece. Okay. And now let's get started and see what happens. So du would be 2x dx, and v would be sine of x. Okay, so now let's go ahead and show the expanded version of this. So if this was u and this was dv, then we would have u times v minus the integral of v du. There we go. And I'm going to take a step and just write this a little cleaner. So x squared sine of x minus, and then it's up to you what you want to do with that too. I'm going to go ahead and factor it out, and then I'm going to write the x in front of sine of x. Like so. Okay. Now notice that the remaining integral that we'd have to figure out still has a product of two functions of x inside. It has x and it has sine x dx. And so this is an example where more than one round of integration by parts would be necessary. And so when I go to the next round, I think I've mentioned before, it's considered poor form to use the same, u and v, for example, to equal two different things. And so u has already been holding the value of x squared. So I need to pick a new letter for my second round of u substitution. So instead of u, I'm going to use a. And so I'm going to let a equal x. And then instead of v, I'm going to use a b. So db would equal sine of x dx. There we go. And I'm just going to go through the same process with another round. So if a is x, then dA would be dx. And if db is sine x dx, then b would equal negative cosine of x. There we go. Okay. So let's get going. So you got x squared sine of x minus 2 times the quantity, because we're replacing that integral with its expanded form. So we're going to have a times b, which would be negative x cosine x, minus the integral of b dA. Alrighty. All right, that is a lot of negativity, so I'm going to take a step and clean it up. So I'm going to multiply the negative 2 in. So let's see, I'd have plus 2x cosine x, and then I've got a triple negative here, negative, 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 so minus 2 times the integral of cosine x dx, like so. Oh man. Okay, and now we're finally to the point where this is kind of a basic rule. So what would you take the derivative of to get cosine? The answer is sine. Now that I'm all done with integrals, I'm going to remember to put plus c, and then we're good. Oh man, are you still with me, my friends? You hanging in there? Gotta wear your big kid pants for chapter 7, okay? This is just the beginning. All right, if that made sense, then give yourself a huge pat on the back. If it did not make total sense, go through it again before you do the next example, okay? All right, feel free to pause the video if you need to. All right, moving on to example 4, integrate e to the x times sine of x dx. So hopefully example 3 made sense, because example 4 is similar. See how it goes. Good luck.